Hello. So this is a video on the lab topic, aseptic techniques, that I hope will be helpful um, in understanding what the lab is about. So as you can see, it's an amateur video um, pressed with time, but I think it will still be effective. So I have my objectives written out here, which are what are aseptic techniques. We need to determine and learn what those are, and why is this topic important. So the word asepsis applies to disinfection and sterilization of protected environments. And so we can define and pull out the keywords disinfection, sterilization, and protected environment. So you already know this, but of course, sterilization is killing all microorganisms, including the spores, which are very stubborn to eliminate. And then disinfection is killing most microorganisms, but not spores. So a very important distinction there. Okay. And then what is a protected environment? So we can define protected environment as any area where you want no pathogens, okay, or as little pathogens as humanly possible, okay. Of course, this is where now the distinction between sterility and disinfections come in, because it's not always possible to achieve sterility. But what is a protected environment? I've given examples here. It can be as big as surgical rooms, or the equipment in the surgical rooms, as small as the equipment in the surgical room. So those are protected environments. And then, of course, I have another example: sterile wound dressing, which is another environment there. You can also have even your sterile gloves are a protected environment. Okay. My own laboratory workstation is also another example of this. The list goes on and on, but we are we are basically saying that in your day-to-day, in your clinical life, you are always trying to have you're always trying to have or minimize the pathogens on all the surfaces, in all the procedures, and so on. Okay, but let's just clearly define it now. Now that we know asepsis, now what is aseptic techniques? That's what I was trying to really hone in on. So aseptic techniques now is a collection of procedures and methods to prevent microorganisms from reaching a protected environment. Okay, so this is preventing the spread of microorganisms. This is prevention. This is infection prevention. Okay, this is aseptic techniques, all summed up. Okay. So as a note there, saying don't forget the detailed examples of sterilization and disinfection methods, because this is on the ground your day to day. For example, of course, sterilization, the first thing we should always think about is heat, right? Your autoclave, that it should come to mind, UV, and so on. But don't forget all the details that you know about sterilization, disinfection in the lecture notes. Okay, so with disinfection, we have an example in our lab menu of a chemical disinfection. Okay, in the very first part of your lab menu there, you have an illustration. But let's continue again with aseptic techniques itself. a bit more on the umbrella of aseptic techniques. To understand the different aspects, we can break them down into four, which I've written down here: environmental, contact guidelines, barriers, and equipment and patient preparation. So, in terms of, for example, equipment and patient preparation, this equipment, of course, has to be immediately we think of sterility, the sterile equipment. So, all methods that we know about sterilizing equipment will be applied there, and then of course the patient also before any sort of procedures where there can be a potential to transmit pathogens or and so on, you have to prepare the patient, right? So, for example, just drawing blood, you have to disinfect your skin surface, right, with an aseptic, whatever your facility would be using, right? So your alcohol swabs, your methylated spirit, whatever it is. Okay, so and then we have barriers as an aspect of aseptic techniques. So this means actual physical barriers that we will put on. So it can be our sterile gloves, it can be our sterile masks, our protective gears, your personal protective gears. Okay, so these are barriers. We are putting a physical barriers between the pathogens. Okay, another aspect of aseptic techniques. And then we have contact guidelines, and this means we are aware that, for example, a sterile surface to maintain sterility must only touch another sterile surface. Okay, so that's a contact guidelines. And then a non-sterile surface can touch another non-sterile surface. Okay, so that is what that is all about, really. And then environmental controls is as it literally can be said, it's an environmental control. So an example is with the surgical room, okay, where that is a protected environment and only allowed personnel can enter. And of course, that personnel is already trying to minimize transmission by making sure they are they have washed their hands, they have of course scrub down and so on. Okay, so we're trying to control the environment, which also then limits the transmission of pathogens. So another example is the isolation procedures. For example, in the TB ward, that's a good example. So an environmental control there, we are controlling the transmission of the pathogen, okay, and protecting one part of the area from another. Okay, anyway, so that's about it, really. These are aspects that you will come across in your day-to-day clinical life. Okay, and now that we know, this is how we accumulate or put rather the collection of these methods together to make the aseptic techniques. Okay, so like I said, your lab manual already has a title there, disinfection, and it's basically trying to show you a practical example of a working solution, a chemical disinfection approach in the lab. Okay, so you can appreciate that in your menu, that solution there and that dilution. Okay. And the next section in your lab menu has procedure for an aseptic inoculation. So this is what your diagnostic microbiology lab will be doing. Okay, so we have to observe aseptic techniques in trying to investigate the infecting agent of the patient, because we want to ensure that as we are trying to culture, stain, or whatever it is, we are only investigating that particular patient sample. We're not also now putting in contaminants or something like that. We just need the result from the sample and nothing else, because we can't afford to have an identification that is not part of the sample that could lead to, of course, treating wrongly, of course, and so on, right? So it's very important. Okay, so in our lab session, we appreciate how an aseptic inoculation is appreciated, and I have a note there here in my view here. I'm saying in the steps for septic inoculation, please make sure that you can appreciate that the first thing is to disinfect the workstation, and then you light your spirit lamp, because lighting a spirit lamp is how a microbiologist is already trying to introduce sterility, because the diameter around the flame is considered sterile. Okay, and so that's where the inoculation happens, very close to the flame in that sterile radius. Okay, so the method in our lab menu there is called a four-way streak method of inoculating. Okay, I have a note there in my view. Don't forget that cultures is a diagnostic too, right? Like I already mentioned anyway, that micro the whole process of aseptic inoculation is a diagnostic too. But let's not forget this, even though we're trying to focus on the aseptic part of it. But this cultures and the plates, all of that, this is a diagnostic too, right? And so the method of streaking and inoculating is called the four-way streak that we're appreciating in our session. Okay, so I can run you through the steps, and of course you have them as well in there, so please follow the steps in your lab menu together with me. So I have in my view something to compress the steps that we have in your menu there. Okay, I should mention that the whole goal of inoculating your bacterium on an agar plate is to try and, of course, grow the infectious agent, but we're growing it in such a way that we have isolated colonies. We need isolated colonies once we have that growth, because it is only when we can identify isolated colonies that we can study those colonies very well and make a proper identification. But let's quickly run through what we can see here. So we have my flame, of course, like I said. I have my inoculating loop near there. Of course, I sterilize it by putting it in the flame. And then I bring my plate towards the flame, near the flame there. Like I said, it's a sterile environment. And then pick my inoculum, whatever it is. Okay, I pick a nice scoop there of inoculum. And then I make my first streak. Okay, I am going to make it into 4 quadrants. That is the principle of the four-way streak. We make streaks in the 4 quadrants. So I'm in my first quadrant with my first streak of my very first inoculum, the one and only inoculum. I only dip once, so to speak. So I streak there my parallel lines in my first quadrant, okay? And then I sterilize. I kill off any leftover from my streak there. And then I proceed and try and now get into my second quadrant by drawing the ends there into the second quadrant, which come into here. Okay? Okay, once I have done that, I sterilize again, killing off any leftover from that dragging, that streaking. Because again, I want to have a reduced amount, constantly reducing what I'm picking up, because the goal is to get to an isolated, to a small amount that will nicely grow into isolated colonies. Okay, so I have that in my second quadrant. So, and then now proceed, like I said, I have to sterilize before I enter my third quadrant, killing off any leftover. And then I do the same as previous, picking up the ends there from the second into the third. I sterilize again, killing off any leftover, and do finally into the fourth quadrant. Okay, my streaks there. Okay, and then I, of course, let incubate, and then I can study my quadrants. So just a quick note on the quadrants and the growth. So this is how my quadrants will look. Okay, my first, second, and third and fourth. The note I wanted to say, the last thing I wanted to say was you expect a lot of growth here because that's my inoculum, that very first streaking, and then after that I'm picking up less and less and less. So the most growth in the first and less growth in the second and even lesser in the third, and finally the fourth will have the least growth as we progressively dilute. Okay, that is the principle of the four-way streak. And there in the fourth, I will find my isolated colonies that I study for what we call colony morphologies. And we have in our lab leaflet what the colony morphologies are. You have the size there in the lab menu, margin, elevation, and so on. Okay, let me just show you a picture of an agar with an actual growth.